Hello. So what had we been doing in the past few weeks? In the past week, we had seen something about integration. We had seen the basic formula, and also we had done one method which is called as the substitution method. What we will do today is something called the integration by parts. This one you had already done in your lower classes, but again, this is just like a revision. So over here, what we are having u and v, where u depends on x, v also depends on x. Then the integration of uv dx, it's equal to u integration v dx minus integration square bracket du dx integration v dx square bracket dx. Okay, so this is useful. This is useful when you are having something that looks like this. Okay, I'm just having an example. So this one, if you try by substitution, it won't work. All right, no substitution will work over here. You can try it. Okay, so when substitution fails, you try to notice that this one, it is in fact a product of two functions. Okay, so you are having two functions. Similarly, over here you are having two terms that depends on x, a product. Okay, so whenever you have something like this, just know that you will have to use integration by parts one way or another. But the problem over here is how exactly do we choose which one is u, which one is v? Okay, let me make it clear what is happening over here, because over here x squared ex, it can also be written as ex x squared dx. Okay, this and this, they are the same thing. Okay, but the arrangement should be done very properly, otherwise it won't lead us anywhere. Okay, if you choose u to be different and v to be different, okay, if you interchange them, it may not work. So we have to choose u and v according as LATE, inverse, logarithmic, algebraic, trigonometric, and exponential. Okay, so by inverse we mean something that looks like this: sine inverse x, cos inverse x, tan inverse x, okay, and all those things, everything that has an inverse. Logarithmic, you already know, it will have something, a log, the natural logarithm most probably. Algebraic, okay, these are all polynomials or constants. For example, if you have x squared plus 1, x squared, okay, x cubed, and all those things. And trigonometric, if you have sine x, cos x, tan x. And exponential, if you have ex, e2x plus 1, and so on. Okay, so we have to choose them according to this order. Okay, so the main problem first, whenever you are trying to do integration by parts, is finding which one you will take as u and which one you will take as v. Okay, just take this one as an example, x squared ex. Okay, which of these will you take as u and which one as v? Okay, just because you are writing them in this order doesn't necessarily mean that this one will be u and this one will be v. It doesn't really mean like that. Okay, because as you have seen, it can also be written in this way. But since you have to choose them according to the order, you will see x squared, it is algebraic, it comes first. Ex, okay, according to this list, it also comes first. That is why x squared will indeed be u, okay, because it comes first in this list. And ex, exponential, it comes last in this list. That is why it will be as the second function. First function, second function. Similarly over here, this one will be the first function and this one will be the second function. Okay, so you have to be very careful. Okay, do not worry, when we are doing some sums, then you will be more clear. Okay, so let us start, okay, with the first example. The first example is find integral x squared ex, okay, the one that we had just shown. Okay, so since the problem is finding which one is u, which one is v, we had already seen that algebraic comes first and exponential should come later. That is why this one will be u and this one will be v. And also take note that whenever you suspect that you have to use integration by parts, it is best that you write I from the very beginning. Okay, so over here, if you use this formula, you will be getting it is equal u which is x squared, integration v which is ex dx minus a very big integration sign, a square bracket, du dx, that is d dx, u which is x squared, integration v which is ex dx, and then close the square bracket, and then you will be having again another dx. Keep in mind, most of you will probably make mistakes over here with the minus sign. Keep in mind that the minus sign is throughout this integration. Okay, throughout this integration, this minus is in front. Okay, so x squared. Now this one, we can easily use the formula, the basic formula that we had done in the first day, which is ex minus integration. We will keep this one as it is first, integration. Now we will first simplify what is inside the bracket. d dx x squared, it is 2x, integration ex, it is again ex dx. Okay, integration ex, which is ex, and then you are having another dx. Okay, so this is what you will be having. You notice now that this minus 2, it is a constant, so you can keep it outside. So this is what you are having. Okay, but again, you notice that this one is in fact a product of two functions x and ex. Okay, so again, you will have to use integration by parts. If you use integration by parts, again, you will have to choose which one is u, which one is v. Okay, so this is it. Algebraic comes first, and then the exponential comes later. So this is what we will be having. So we will use the formula again. So this one stays as it is because you are no longer having an integration sign. So it will be equal x squared ex minus 2. Now again, keep in mind that this minus, it's throughout, so I will keep a very big bracket. So integration of this one, now we can use this formula again, which is u which is x, integration v, integration ex dx minus a very big integral sign, d dx of u which is x, integration ex dx. Okay, so this is what we are having. Okay, I don't need this anymore. So I will just write it down, minus 2, square bracket, x. Over here we are having ex minus an integral sign, d dx of x, which is 1. Okay, I will write it down. Okay, and integration ex dx will give you ex, and then you will still be having this dx. So this is what we are having. Again, I will still keep this square bracket, minus integral of ex. Okay, 1, it is a constant. Okay, we can easily erase it since it won't affect anything. Minus integration ex will give you ex. Okay, and then since we no longer have an integral sign, so we will write plus c. So we can remove this bracket. We will be having this. Okay, so this is the final solution. Okay, so sometimes you will have to use integration by parts 2 times, sometimes 3 times. Okay, and if you are lucky, only 1 time in a single sum. Okay, for this problem, we did integration by parts 2 times. And again, how do we know that we have arrived at a solution? It is when we no longer have an integral sign. Okay, so keep that in mind. So this is the solution for the first problem. Okay. Now let us do another problem. The second problem, it will be a bit simpler. Let us hope. X log x whole thing square dx. Okay, so again, we will denote it by I from the very beginning. This is very important. Which one should we take as u, which one as v? Okay, we have 2 choices, u and v, okay, a product. Now which one comes first? Okay, according to that rule, ILATE. L comes first over algebraic. This one is algebraic. This one is a logarithmic. So L comes first, so you will take this one as U and this one as V. So you will use the formula over here. Okay, integration UV, which is U log X whole thing squared. Integration V, which is X minus a very big integral sign ddx of U, which is log X squared. Integration V, which is X dx. Okay, so this is what we are having. Now we can use the formula for this one, x power 1, which is x squared by 2, minus integration ddx log x whole thing squared, which is 2 log x ddx log x. Integration of x, again it will be x squared by 2, and then you will be having this dx here. So this one you can simply write it down as x squared log x whole thing squared upon 2 minus this 2 and this 2 will get cancelled. So you will be having, and over here you will be having an integral sign log x, and this one ddx log x will give you 1 by x, and over here you will be having x squared dx, so you can cancel them. Okay, what I will do next, okay, I don't need this line anymore. So this one will stay as it is because there is no longer any integral sign. I will just have to keep on writing it, minus log x, and over here we are having x, so I am writing it like this, x log x dx. Okay, so still we are having a product of two functions again. We will have to use integration by parts again. Take this one as U, logarithmic comes first, and then the algebraic comes later. So this one as U, this one as V. So this is what we will be having. This stays as it is, minus. Since this minus is over this whole integral, that is why I am writing a very big bracket. U, which is log x, integration V, which is integration x dx, ddx U, which is log x, integration x dx, and then you will be having another dx, and then close the big bracket. And over here we will be having log x, integration x again will be x squared by 2, minus ddx log x will give you 1 by x, integration of x will give you x squared over 2 dx. So this is what we are having. Still you see that there is still an integration sign. Okay, so we cannot say that this one is the solution. What we will do next is we will integrate it again. So I will keep this one as it is, minus x squared log x upon 2. Okay, minus 2, you can take it outside. It becomes 1 by 2 because it is in the denominator. So it becomes 1 by 2 x and this one. So you will be having integration x, which is x squared by 2 plus c. And over here it is multiplication. So we can finally write down 1 by 2 times 1 by 2, which is 1 by 4. Okay, so I'm skipping a few lines, and this one will be the final answer. Again, this one, it is the final answer because there is no longer any integration sign. Okay, so we are done with problem number 2. Let us just go ahead with the third problem. Okay, sine inverse x 1 minus x squared dx. Okay, so this one it can be done in different ways. Okay, so let us just try to do integration by parts. To you, it may not be clear that this one is in fact a product of two functions, because we can actually write down this one as sine inverse x. Again, I forgot to write I. We can write it like this. So when we write it like this, now it becomes a product of two functions. Now it is just a matter of choice. Which one should we choose as u, and which one should we choose as v? Okay, so what we will do, all right, okay, so if you notice, okay, if we do integration by parts directly, it will get a bit complicated. So that is why what we will do, we will try to substitute. Okay, how do we know that we will have to substitute? It is because that if you differentiate sine inverse, you will be getting 1 by root over 1 minus x squared. Okay, so this is in fact a problem involving substitution as well as integration by parts. Okay, we can do it directly, okay, but we can also choose to do it differently, okay, which I will do. Okay, so I will substitute first. Let sine inverse x equal z. So you will be having, if you differentiate it, you will be getting 1 minus x squared equal dz dx. So you will be having that dx will be equal to dz. Okay, so this one is actually a very simple problem. Sine inverse x has become z. Dx by root over 1 minus x squared, it has now become dz. Okay, so you will only be getting z squared by 2 plus c, which is sine inverse x whole thing squared by 2 plus c. Okay, so we can easily do it like this. Okay, we don't even need integration by parts. So what I want to highlight over here is that just because you think that it is a product of two functions doesn't necessarily mean that you will have to use integration by parts. In fact, sometimes just by pure substitution, the problems become easier. Okay. All right. Okay. So problem number 3 is done. Okay. Problem 4. Problem 4, I will write it as integration log x dx. Okay. So this one, if you notice that, okay, some of you may be writing this one as 1 by x plus c. Okay, this is wrong. Okay, because you are doing integration and not differentiation. Okay, if it is differentiation, ddx log x, it is indeed 1 by x, but integration log x, okay, it is not, it is wrong, okay, if you write it like this. Okay, and also if you take a look at the formula that I had given in the first day, you don't have a formula for integration log x. Okay, that is because it is not very basic. We will in fact have to use integration by parts. But be very careful. If you have to use integration by parts, some of you may be thinking, okay, this one log is another one and x is another one, okay, which is wrong. Okay, so if you cannot proceed anything, this is one of the things that you can do. Okay, we will make it into a product of two functions. We can write it as I. Okay, I can write it as 1 into log x. It is still the same thing. It's just that I have introduced 1 so that we can use integration by parts. 1, it is algebraic, okay, because it is a constant. And if you notice, we are having a logarithmic and an algebraic. So which one will you take as your first function? Of course, the logarithmic u, and this one as v. So if you use the formula, you will be getting log x integration v, which is 1 dx, minus integration ddx of u integration v dx. So this is what we are having. integration of 1, which is x, d dx log x, 1 by x, integration of 1, which is again x. So this is what we are having. So x log x minus x and x will get cancelled. So we will be left with integration of 1 again, which is x plus c. So no more integration sign. So this one will be the final answer. Okay, so this one is actually very simple. It's just that the first step, you need to remember that you have to write 1 in front. Okay, so question number 4 is also done. Now let us just move ahead with question number 5. Okay, so if you are noticing, each and every problem, they are a bit different. Okay, so let us see number 5. Number 5 is also different from what we had done. Integration ex sine x dx. Okay, I will just keep this in mind. Ex sine x dx. Okay, keep in mind that our original problem is this. Okay, so I'm writing it as I. We need to find I. We need to find I. So again, we will have to use integration by parts. Which one will you take as your first function? ILATE. This one is trigonometric. This one is exponential. So you will take this one as u and this one as v. Okay, and then you will use the formula. You will be having sine x integration v, which is ex, minus integration d dx u, which is sine x, integration v, which is ex. Okay, so this is what we are having. Sine x, integration of ex will give you ex, differentiation of sine will give you cos, and then you will still be having ex dx. So this one we will keep it as it is. Okay, I'll just write ex in front, minus, and this one again, it is a product of two functions, which we will have to use integration by parts again. Okay, so this one, it's an integral sign, and this minus is for this whole thing. That is why I am writing a square bracket. So which one will we choose as u and which one will we choose as v? Okay, so if you notice, we will choose this one as u and this one as u and this one as v. Okay, d dx cos x, integration ex dx, and again dx. Okay, I'm writing it very quickly. I'm almost out of battery. Okay, so this one we will get ex sine x minus integration cos x. Again, this one we will get ex minus d dx cos x will give you integration sine x. Sorry, this one it's a square bracket. D dx cos x will give you minus sine x. Integration ex will give you again ex. Then you will be having dx. Okay, keep in mind that we had been calculating I throughout. Okay, minus into, okay, you will be having ex cos x. Minus into minus will give you plus. Plus into minus will give you minus. You will be having ex sine x dx. Okay, I'm just writing ex in front and sine x to the back. Okay, if you notice that, okay, we can do integration by parts again, but it won't lead you anywhere. So what you will notice now is that you can write this one simply as I. Okay, you can easily replace it with I. Again, I is everywhere. And over here we'll be getting minus I. So keep in mind that we need to find I. So take I to this side, you will be getting 2i. Therefore, I, you can divide by 2. Divide by 2 plus c. So this one will be the answer. Until next time.